Okay, we have a matrix here that's 3 by 3. Do not count the totals that are around the outside, okay, in your count. So you need to go to your TI-84 and enter in a 3 by 3 matrix and then perform the chi-squared test. Some of this other stuff you can do by hand, but we're going to need the TI-84 for sure. Okay, state the null hypothesis, H0 for the test. What this means is this is the chi-squared test for independence. So we're going to say that one variable is independent of the other. Okay, so you got your variables yield and fertilizer. So we can simply just state yield is independent of fertilizer. Okay, use the word independent and you'll get credit on the exam. Okay, and then the number of degrees of freedom. There are no formulas for topic 4 in the formula booklet, so you're going to have to memorize it or just understand what degrees of freedom mean. We're going to be moving from this square here. How many places can we move? 1, 2, 3, 4 maximum. So the maximum that you can move in the matrix is the degrees of freedom, and that calculation is a simple one that we just do rows minus 1 times columns minus 1. Okay, and that's degrees of freedom. The calculator will also give it to you in your chi-squared calculation. Okay, so we got 3 minus 1 times 3 minus 1, that's 4, like I said it would be. Okay, write down the critical value for the test. Time to use the TI-84. We're going to input a matrix. So you need the blue matrix, and we're going to edit a matrix, and I said the matrix is 3 by 3. And you can see I've already put in all the data for the observed frequencies in the matrix. High yield was 10, 8, and 12, etc. All right, so now that that is done, I want to quit out because I like to always start with a clear screen. And I'm going to go back and do a stat test on this matrix. Okay, so stat test. And I don't see chi-squared anywhere here, so we're going to have to go to the bottom of the screen or up from the bottom. That's what I do. And there's the chi-squared test, x squared. All right, and then the matrix that we wrote our observed values in was A. The test will write the expected values in B, and voila. And you can see it gave us our degrees of freedom at 4, and it gave us a critical chi-squared value for the calculated chi-squared value. Okay, so that is actually down on question E over here. The critical value for the test, which was asked in this question, you actually get from a chart, okay? But for the exam, you're going to be given that critical value based on the degrees of freedom and your confidence level. This was, I think, 1% confidence level, which means there's only 1% chance that this variation in data was due to randomness. And the degrees of freedom was 4, so we simply looked that up. And we got a critical value that's given on the exam of 13.277. Okay, so that should have been given there on that question, but this is an older exam. Okay, so we're going to compare, we're going to look at the expected number, medium yield crops using fertilizer C. medium crops, fertilizers C. So that's in this position in the matrix. We could go back and look at the matrix here and see that they did in fact calculate 17. Look at matrix B now because that's where it's written. And if I look over here to the right, I don't see 17 anywhere. Okay. Because this is my observed matrix. I thought I was, oh, see, it says matrix A here. I should have looked at matrix B. I thought I went down here, across here. I want to edit matrix B. So I think I got to edit first. That's what I did wrong. Edit B. Okay, sorry for that. Round that up to 17. Okay, how is that calculation performed? That calculation is performed by proportions. Okay, again, we can look up in our matrix and we can see that we're looking for these proportions. This proportion is 50 out of 120, and this proportion is 40 out of 120. So basically it's just 50 over 120 times 40 over 120 times 120. So that's a proportion of an amount. And you can see the 120s cancel out. So all you have to do is multiply 50 times 40 and divide by 120, and you get approximately 17. Okay, back to the chi-squared question, the calculated value. We got that calculated value off the TI-84. Again, it was stat test C, I think it was, but I'll do it that way. And there's our calculated value, 3.98, okay, to 3 significant figures, okay? And the p-value is also given on the calculator. The p-value is 0.409, which is about 40%. So we have a high p-value and a low, we have a high p-value, yes, and a low chi-squared calculated value. Basically, that means that we're going to accept our H0, our null hypothesis. What we're looking at is on the horizontal or x-axis